Okay guys, now we're going to do number 6. I promise my video skills are hopefully getting better. I'm sorry, my head was in the middle of the last one and half of them have been upside down. I think that this is going to be my first right side up one, so get excited. Okay, so we're doing number 6. Number 6 says an arrow is fired horizontally with a speed of 89 meters per second. Directly at a bullseye of a target that is 60 meters away. So 60 meters away, we have a target. When it is fired, the arrow is 1 meter above the ground. How far short of the target does it strike the ground? So what this is telling us is, yes, the bullseye is 60 meters away, but it's not necessarily going to make it there. So this arrow is going to come down and it's going to strike the ground short of the target. So the target is 60 meters away, but the arrow falls some distance from where it was shot, dx. And if we can find dx, then the difference between 60 and dx is what we're looking for. That will tell us how far short of the target the arrow fell. So to start this problem, let's get it set up in our table. The important thing is going to be to try to remember not to put 60 meters in as the x difference. I think that's going to be the most common mistake in this problem. So I'm putting in all of the normal things. Acceleration, x initial velocity, negative for the y. We know that it's shot from 1 meter high, so it is going to have a y distance of negative 1 meter, and we know that its initial velocity is 89 meters per second. So therefore its final velocity in the x direction will be 89 meters per second as well. I am not putting 60 meters anywhere in this chart because 60 meters is the distance that the target is, and it's not the distance that the arrow is actually going. So I'm going to leave this 60 meters and come back to it at the end. Now this is just the same as problems 1, 2, 3, and 4. We're going to use y to find the time and x to find the distance. To simplify this, 1/2 of negative 9.8 is negative 4.9. To get time on its own, I divide on both sides by what it's multiplied by. That would be 0.2 seconds squared. I now take the square root of that. That would be 0.45 seconds. 0.45 seconds for our time. We go back and plug this in. If you guys are getting lost on any of this part, I'm going through it quickly because, like I said, it's the same as numbers 1, 2, 3, and 4 for the most part, where all we're doing is solving for the time and then the distance. So if you're getting confused on how we chose this equation or why we're having to find the time, go back and look at the videos of 1, 3, and 4. This one I'm just going to keep moving through. So we found the time. Now I'm looking to find the x distance because that's what we need to answer the question. We can use equation 2 or 4. I'll just use 4. 1/2 of 89 plus 89 will be 89. We'll multiply that by the time. That gives me 40.21 meters. So the arrow went a total, dx is 40.21 meters. The arrow went a total of 40.21 meters. The question was, how far did it land from the target? So now I'm going to say 60 meters minus 40.21 meters. Which will give me 19.79 meters from the target. So that will be our answer to number 6. I've seen a few different answers just by a little bit, probably just because of rounding. So if you got somewhere in this 19 range, you're fine on number 6.